Hello, this video series is getting started with regression analysis. This is video 4, modifying coefficients for line item adjustments. I'm David Braun with Automated Valuation Technologies. Feel free to go to the website and look for other educational videos, and also feel free to contact me by email with comments and questions. Now, this video is a little bit different. It works together. There's a document and this video. So if you haven't downloaded the PDF document, hit pause, download it, and then read to the point it directs you to come back to exercise 1. All right, let's go to exercise 1. This is a virtual market. That basically means everything in here is hypothetical. I've created it. Okay, there's about 50 sales. Well, there's less than 50 because it starts at 4, so it's 4 minus 51. So it's what, 47 sales or so? Oh yeah, it says so there, 47 sales. All right. The sales prices on each of these is based on these property characteristics: the site, gross living area, pool, date, garage, and age, times these coefficients. See, since this is a virtual market, I've kind of built this model backwards. You know, it's a market, but I actually built a model, then I called it a market. And that's what makes it virtual. So I know the coefficients when I run Excel will be 60,000 per acre, $100 per square foot for gross living area, 20,000 for each pool. The date has no value. The garage is worth 6,000 a bay, and for each year take off $3,000. That could be effective age maybe, and take off $3,000. Now, there's no variance built into this model. This is exactly, I think I've shut the formula bar. No, the formulas aren't in here. I made them earlier and copied it over. But let's go ahead I'm going to put this step in so nobody gets confused in what we're doing. Normally, you would take your data and you'd run it in a regression program. All right, now let's go back. Actually, this is one I just ran a second ago, so we'll start it over. I have to bring my data over, my little box over. It opens in the other screen. See, I'm going to open this from the clipboard. And the only thing I have to scrub is my dates, turn them to day since sale, and I'm going to go ahead and change the date to January 1. Everything else should be right, and since I just did it, it's even put them over here for me. So now that's our regression model. Now you'll notice that the day since sale, which is time, the P value is red. That means that there's probably no relationship between day since sale and value. And we know that because we built the market. There was zero effect, so we're going to turn that off. It's a stable market. Then everything else came across, and you can see here, this shows our residuals, and they're all right on the line. We have zero residuals because there's absolutely no variance built into this market. And you can see the side is 60,000, the gross living area $100 a square foot, the pool is 20,000, the garage is 6 per bay, and the age is 3,000. So let's go back now to our Excel. And our question is, if we have an Excel model and we have coefficients, do we just plug them in? Do we simply plug them into the adjustment grid? So let's go to exercise 2. Exercise 2 is the adjustment grid. It has 6 comps on it. Each of these comps came out of this somewhere. And they're set to adjust automatically. Let me click here. For example, it's it's something like the subject minus the comp size times the amount over here, times this coefficient. So I can apply these coefficients to the subject, and I'm going to know its value. The value of the subject is 187 because I took 23 times a minus 3 and 1 times 6, 1 times 20,000, so on, and I know that adds up to 187. So if my adjustments come up right, they should all come out at 187 because I'm adjusting them to be like the subject. And because there's no variance, they all came exactly out to 187,000, which tells me is it's okay to bring your coefficients and put them straight into your adjustment grid. All right. So, but we're not going to stop here. We're going to come back and question this theory in a second. So don't turn off the video and walk away yet. So let's pause, and in a second we'll do exercise 3. All right, this is exercise 3. This is a very important appraisal theoretical concept that's important for appraisers to learn. These are two racers here, racer 1 and racer 2. And what we're going to do is let them have a race. But before they race, I'm going to let racer 1 have a head start. Okay? So now when we blow the whistle and say go, they're going to go. And they're going to keep moving here. We'll get up to the next line. And they're going to end up here. Now, 1's still ahead, but not quite as far ahead. But 1 is still ahead of 2. Now, the race is still going on, so let's keep them moving. I know all of you have seen this in an appraisal class sometime or another. I'm being facetious. I'm sure you haven't seen it. So as these move, now racer 1's hit this line, and racer 2 has hit this line. Now notice they're closer together. So racer 2 is actually gaining on racer 1. But let's think about something just a minute. No matter what happens, as long as racer 1 is moving forward, as long as racer 1 is going and not sitting still, by the time 2 gets to where 1 is, time has to have passed, so 1 will be ahead. Let's do this segment of the race. So they race, and as they come here, now 1 is 2's even gaining more, but no matter what, and see, we can see these are getting smaller over here, but no matter what happens, by the time 2 gets to where 1 is now, because 1 started with a head start, no matter what happens, time will have elapsed. This is logic, and see, we're talking about using logic now, and reasoning, is that 1 will always be ahead. Okay, so we've established that racer 2 can never pass racer 1. Well, what we're looking at here is Zeno's famous paradox on motion. And racer 1 is a tortoise and racer 2 is a human. Now we know if you set from the very beginning, we know that if you set these a tortoise and a human running and you give the tortoise a head start, that's fine. But we do know that eventually, that the human will pass the tortoise. We know that. That's common sense. So how did we just arrive at the fact that they couldn't pass, and now I'm telling you by common sense they can pass, okay? And I like to call this an exercise in absurdity. And that's one of the tests that appraisers always have to apply to analysis output. Any analysis you run, the output you see, we must always, one step that you always do is an absurdity exercise. Now in appraising, we might call this getting lost in our numbers. And I've seen appraisers do it. The numbers circle them around so deep, they come to a conclusion that just really anybody that backs out away from it would say that can't be right. So now that we know the importance of an absurdity test, let's go back. Let's go back. We had the adjustment grid that we put in, and everything came out just right. We put these in. Each the subject is 187,000, and since there's no variance, the comparables should adjust, and every one of them came to 187. But let's stop and let's do a couple absurdity tests. Now the first one I'm going to do, and I'm going to unhide these cells so I don't while I'm at it. But let's go back over here. Excuse me. And one of the things I want to see is what is the sales price per square foot here. So let's take sales price per, and we had gross living area, so I'll just stay true to what we used. And that's equal to the sales price divided by the gross living area. All right. And we normally want a couple spaces, but I'm not too worried. We're not trying to be that careful. There they all are. Now let's find the average of them. Equals the average of all of these numbers. I'm going to hit enter. And the first thing I notice is that these houses are not new houses. They're older houses. 17, one's 25 years here. So they're all different ages, but they have an average sales price per square foot of 107. Okay. So if I think about this from an absurdity standpoint, I'm saying that the sales price is like a function. See if it'll let me leave the equal sign in here. It's like a function of all these things we looked at. Site, gross living area, pool. So we have site plus, with the gross living area, we already figured that in the sales price, but site plus pool. What else did we have? Plus garage. All of the things that we had. Now let's go up and look. Did I get them all? Site, pool, garage, date. There wasn't anything in the date. Mainly those three. Now, I said sales price, but actually here it's sales price per square foot. I'll just do that. And I know that this is kind of what it's made up of. And I know that the average is 107. Whoop, I'm not a very good typist, am I? 107.45 per square foot. Now, if I give 100 of that to the gross living area, that leaves me with, and I don't even have to, I can do it in my head, leaves me with $7.45 per square foot for all of these other things. Now, what does that mean in English? Well, we might want to find the average. Let's just do this. Equals the average. It's got a loud keyboard. Equals to the average of the gross living area, enter, and that's 1819. So if we figure that, that would be equal to the 1819 times 745. That means in this model that we're showing, $13,550 is what's left for site, pool, and garage. I don't know if I buy that. First of all, I don't know. Something doesn't ring right with that to me as an appraiser, because I know my garage alone is if you're a 2-car garage, that would be $12,000. A site 60. So something doesn't seem right to me. Now, we're getting into advanced techniques, and I'm going to be honest with you. We're getting into things that I'm just now studying. And if you read the manual, it'll tell you kind of what or the manual, the document that's associated with this video. It'll tell you what I'm working on now to help answer these questions. But you're using this today, so I can't wait. I want to warn you today that this doesn't look right to me. Okay, that's one absurdity test. Now, I'm going to go back to another absurdity test. I opened these up, and these were other little adjustment grids up here. And I put a comp in for 3,000 square feet because I want some contrast here. Everything else is the same in this comp, between the comp and the subject. They're both 40 years old. And then I did another one. Everything's very similar to this one, except they're new houses. Okay, so if they're new houses, and this calculation's down here, simply tell me what the number should adjust to here. So I know it's 136, and I'm not going to get into those calculations, but the number should be 256, and it does adjust to 256. So I like what it adjusts to, but there's something that bothers me here in my absurdity test. One of the issues is that if I adjust a brand new house with a market modeling technique like regression, I get $100 a square foot and I put it in. Now, if I'm doing a 40-year-old house and I put $100 per square foot in, the number comes out right. But as an appraiser, I don't think an incremental value on a 40-year-old house should be the same as the incremental value for gross living area on a new house. If the new house is 100, I'd expect a 40-year-old house, the incremental value, to be less. Okay? So there's two things in the absurdity test that I don't like. So let's stop here And basically we covered, this is basically the end of exercise 4. All right, now let's go to exercise 5. Now in exercise 5, we have some real data, and you'll notice that I have some things marked in yellow because my tip to you is if you have to scrub data in your software, if your regression program doesn't scrub it for you, excuse me, I like to mark them in yellow so I can't forget them. So let's just go ahead, let's go to Control All and copy. And now I'm going to drag this out of here because I want to be able to see it if it will let me drag out. I guess I have to open this back up. And let's see if it will let me drag it out of here. There it goes. All right, now I'm going to put it in the regression. I want to be able to see my yellow marker. So let's go to File, New Valuation. And we don't want to save this last one we did. So it opened in another window. So I'm going to bring it in from clipboard. All right, let's go next. So now I got to think a little bit about my adjustments because we're going to have to do a little scrubbing with the data. So let's go to sold date, and I think we want this still to be, I'll do January 1. I'm not positive. I think it's January 1. All right, now I'm going to go ahead and divide the sales into 120-day intervals for market conditions, and this is going to automatically set up some dummy fields. I am going to go ahead and combine the baths, the full baths and half. So full baths is called in my MLS baths full, half baths is called baths half. And when you can, always use the age of the property instead of the year built, because if you use the year built, you'll get an outrageous coefficient. It's year built versus when it's sold. That's how it calculates. Now when I go over, I'm going to say yes here. Now when I go over, there's only 2 fields I have to deal with. One is the everything else is numbers except the subdivision. There's 2 subdivisions, so I'm going to set up dummy fields for those. And it looks like there's 31 in one subdivision, 23 in the other. And basement is either yes or no in this case. They all had either unfinished basement or no basement. So I'm going to do just a vertical rating because all I want is a yes and no in this case. Does it have a basement? And remember, a 0's for no, a 1's for yes. So that takes care of that. And then in a pool, it's kind of the same thing. I just want a 1 for yes and a 0 for no. And here it says there's 5 records with pools. Okay, and I'm going to look over here and make sure I have all these. So I think I've done all the scrubbing now, so we can go next. And let's bring our information over. The sold price goes as our dependent variable. The house numbers, a description, street names, a description, and most of these others, bedrooms, basement, pools, property age, total baths. I'm going to go ahead and bring both of these subdivisions, remember, and the MCI fields. These are dummy fields. And you always have to turn one of the fields off. I bring them both in, then turn them off. You could have left one out right here. It doesn't matter. Okay, so here we are. And right off, I know that I have some red. One reason, and I'm not going to go through my whole proper regression analysis that starts with the data because I've already done that. Okay, so this is kind of making another point than just how to run regression. But I do know I have to turn off one of these dummy fields. Now, I know Allenbrook is worth more than Ralston View because I appraise it all the time in that area. All right, now it's not picking up my bath, and I always have trouble with bedrooms and baths, so I'm going to turn these off. In most of my markets, I have trouble. And we're going to talk more about these adjustments in the document. So we're just going to go through and reach a point, then we're going to we may stop in a minute, then we'll look at it in the document in a second. Now, all right, so let's look at what we've got so far. Now I'm going to look, one of the things that we're concerned with is the market condition analysis, and I can see that my day since sale, and they work a little bit different. Mine says $32 for each day going back, which means even though it's negative, that really means it's a positive. And let's just go ahead and let's look at our dummy fields. We set up dummy fields of time, and let's go ahead and look at these real quick. Just get through this, because we may want to know if there's a relationship. We want to know, is it maybe curvilinear. Now I've got those in. Remember the rule, you can't measure the same thing with two variables at the same time. So I need to turn day since sale off. Okay. Now let's go up here and let's just take a look. All right, so you can see, I can see on the day since sale, it was looking at the straight line relationship. So let's look at a straight line. That's what it was seeing. Probably not much difference in reality that this shows. Now what I like to do is go till it gets funky and come back till you can still, I'm sorry, I went the wrong way. Come back till you still see the story. One doesn't tell the story. I think maybe two does. So there's maybe a slight curve we could leave in there. And we know we're going to have to turn one of these off. Maybe we'll do this one. It doesn't really matter, but we're going to have to turn one of these off. What does this tell us about our appreciation? If we had a straight line, let's go ahead and set it back to a straight line. Let's make up one about a year back from this sales date. Let's get our map, and let's go back to 14, and let's go to January 1, 14. That's 1 year back, and we'll just make up a number, 100,000. And it's showing like a 10% appreciation rate. So a pretty good appreciation rate. But you can look back, this data starts back in 11. That's when we were coming pretty strong out of the housing crash. So if I go up and put 2 in, it shows it going steady, but then it goes a little bit steeper. It's actually 16%. So I can get my market condition analysis here, and I'm glad to get that. Now let's close this. All right, let's put in some subject information. I think I've got some subject information. Here it is. I got notes all over the place. Let's go to valuation setting, and day since sale should be 0. The square foot for this one happened to be 1,700 square feet. The basement was 1. The age was 12. I'm going to jump around a little bit. These aren't in the same order. The baths are 2. And we were in Allenbrook, so Allenbrook should be 1. That should be 0. The bedrooms is 3, and the in-ground pool should be 0, which means doesn't have it. It's a no. And then the market, this one we're trying to appraise in the last, make that a 1. We're trying to appraise that in the last group of sales. Okay, so there's our approximate value. So we have approximate value. We know there's a lot of appreciation. We got to go down here and get rid of one of these. I don't know that it totally matters. What we normally do is probably find the one. Let me see if I can bring this down just a little bit here so we get a little better look. I'm on a smaller screen than I usually use when I record, so everything's set for a little bigger screen. What I would normally do is turn off one of these that gives me the most green over here in my in this p value, because they're dummy fields, so one has to be turned off. So I'll just turn that one off. I'll turn 6 off. I think it could be. Let's see if 5's any better. Well, when I turn that one off, let's see. Yeah, it's about the same. So make sure I've only turned 1 off. So I accidentally turned 2 off. You only want to turn 1 off. All right, so now let's come up and see. Now we've got something in red here. Is Allenbrook. I feel strong about Allenbrook. I know it's better. Property age, though, I'm in real data here, and property age doesn't matter as much as property condition or true effective age. This is just age. Now, because these houses range in ages, I'll click down here and look from, looked like, let me get to the top. It looks like from 10 to 26. I don't know which ones have been remodeled or not. I know I'm very suspicious that means anything property age, so I'm going to turn it off. And then I notice I get Allenbrook back about 10,000 better, and I believe that's correct. So let's see what we've got here. We've got $83 a square foot. Let's remember that. We got a basement, a pool at 34. And then we know we have appreciation. So we're going to stop here just a minute, but before we go on, I want to remember my total square footage coefficient was $83. Now what I want to do here is kind of like we did in the other one. let's find our sales price per square foot here and see what the average is. So we'll come here and put sales price per square foot, and that is equal to the square footage divided by the oops, sorry, I got it all wrong, didn't I? Let's go over here and try that again. It's the sold price divide by, and I may have to go back and start over. I don't like the way this is looking. We better start this over. Is equal to, square foot is equal to the sold price divide by the total square footage. Now we got it. Now let's pull this down. Okay, and I want to know what the average of that is. So let's just come over here and put equals average of these numbers. Almost hit delete. And I'm 92. Now our return for the coefficient for size was 87. Now, in my absurdity test, those seem too close to me. Okay? Those seem too close, so I would be hesitant about using these, okay? Now, we're going to talk about in the manual why this might be and is there an issue or not. So we'll do that in the manual. So this ends exercise 5, and now let's return to the manual.